Okay, so today we're going to go over complex numbers. Complex numbers consist of a real number and an imaginary number. An imaginary number is not a real number. The imaginary number system allows us to find answers to equations that we could not find answers for in the set of real numbers. The set of imaginary numbers are numbers that have negative numbers in the radical that has an even index. For example, the square root of negative 1, square root of negative 4, square root of negative 7. Imaginary numbers have an I in them. Imaginary numbers in simplest form do not have a negative in the radical, and the exponent on I will never be greater than 1. Okay, so by definition, the square root of negative 1 is I. And we're going to go over more of those exponents in just a second. So starting in the next paragraph, the square root of negative 5 equals the square root of negative 1 times the square root of 5. And that equals I radical 5. Also, the square root of negative 25 equals the square root of negative 1 times the square root of 25, and that's 5i. When simplifying expressions with imaginary numbers, you must take out the negative before performing any other operation. Complex numbers are written in the form a plus bi, where a is the real number and bi is the imaginary number. Okay, so first of all, last week when we were solving equations or solving for the roots of an equation by graphing, sometimes you had a situation like this where it did not intersect the x-axis at all. And in this case, last week you were writing no real solution for this type of a graph. But now with imaginary numbers, we're going to be able to find values for those roots. Okay, that's what the whole purpose of this is. So a complex number in general form is like this, a plus bi. A is a real number, so it's rational or irrational, it doesn't matter, it's just a real number. But this other part is the imaginary part because it has the I with it. So you can have a complex number written like this, where this is all together, you don't split that apart. Okay, you treat I kind of like a variable whenever you're working with it. Or you could have just the imaginary part, that's considered complex as well. But whenever you have just a real number, you don't consider that complex, okay? Just these two situations. Okay, so let's look a little bit at radicals. I know you guys have done radicals before in Algebra 1 and probably geometry, but I want to brush up a little bit on that. It's been a while. You might be a little rusty. So, for example, I just want to start with this real straightforward square root of 9. What is the square root of 9? 3. Okay, so how do you know that it's 3? What process are you thinking in your mind to arrive at 3? 3 times 3. So you want 2 of the same factors to get it out of the root, right? Because this is a square root, so that means 2 of the same factors. So when you have something like this, the square root of 8, you're not going to put it in your calculator and get a decimal number. You're going to leave the answer in radical form. So you have to break this down into prime factors. 2 times 2 times 2. That equals 8 when you multiply them all together. And I can group a pair of 2's together, so that means I can take a 2 out. But then you have this leftover 2 that doesn't have anything to pair with. So that would have to stay inside the radical, and that would be your answer, 2 radical 2. Any questions? You guys remember doing that pretty good? Okay. So we're going to be doing some of that today, but we're also going to throw in some radical, that have negatives inside. So let's look at the i's now. So by definition, for an imaginary number, the square root of negative 1 is I. So you don't have anything that you have to pair that with, right? It's just that one factor of negative 1 gives you I when you take the square root of it and you simplify it. Okay, so if you remember from previous years, when you had a square root times itself, the answer would just be the number that's inside the root, because you're squaring a square root, so it kind of reduces each other out and you're just left with that number inside. Okay, so if I square I, that means I'm taking the square root of -1 times the square root of -1. And when I multiply square roots together, if they have the same number inside, the answer is just that number. Okay, so I squared is -1. So these two concepts is what we build all of the other I to a power on. Remember, in the notes it said that for I to be in simplest form, you can't have an exponent bigger than 1. So if they give you an I with a power higher than 1, you have to know how to simplify it. So let's do some examples of that. Okay, so I'm just going to keep adding on 1 on the exponent, and we'll repeat it. So I to the third power. When you have an odd exponent, the first thing you want to do is break this down into I to a power that's 1 less times the leftover I. Okay, so now I have an even powered I times I to the first. I squared, I know from this previous step, is -1. So I'm going to replace the I squared with -1 times I. And that's going to give me a negative I for my answer. Okay, let's go one more step. I to the fourth power. So when I'm simplifying an even power, my first step here is I'm going to write I squared in parentheses. Okay, that part is always the same. That stays I squared inside the parentheses for every one of these even type problems. And the number outside the parentheses, I need to divide this exponent in half. So 4 divided by 2 is 2, and that goes on the outside in this case. And we'll do some more in just a second. But remember, when you have a power raised to a power, you multiply them together. And so if I multiplied those two together, I would get the 4 back. So I'm just like breaking it down. Now the I squared is -1. So I'm replacing the I squared in the parentheses with -1. And when you square a -1, is it going to be a +1 or a -1? Positive 1. So that's going to be your simplified answer. So any even exponent, when you take a negative number and raise it to an even power, it's going to be positive, right? If you have a odd power raised, a negative number raised to an odd power, it's going to keep it negative. And we're going to do one of those next. I to the fifth. Okay, so I want to see, these are my two basic ones. All the other ones are going to be patterned after that. So let's go back up here to this odd power. I broke it down into 1 exponent less times the I that's left over. And I'm going to rewrite this I to the fourth just like the previous step. So I want my I squared to be in parentheses. The exponent on the outside is the original divided by 2 times the I that's left over. Okay, so I know that this is going to be a +1 because of my previous exercise, and 1 times I is just I. So there is a pattern that's happening. The very first is 1, then you have -1, negative I, positive I, and now it's starting over again with a positive I. So my next answer, if I go up one more exponent, should be a -1 because the pattern is just going to keep repeating. So let's try I to the sixth power. Okay, I have an even exponent, so I want to pattern it after this I to the fourth. So I'm going to have an I squared inside parentheses, and the exponent on the outside is half of the original, so it's going to be 3. And I squared is -1. -1 raised to an odd power, is that going to be a +1 or a -1? Negative 1. So that's your simplified answer. Okay, so let's just do one more. I to the 7th. So I want to rewrite that as I to the 6th times I. And this I to the 6th I just did. And I got a negative 1 times I will give me a negative I. So we can put any exponent we want to on the I and be able to break it down in these two ways and simplify it. So let's do one that's really big, like I to the 56th. All right. So I have an even exponent, so I want to pattern it after this one. I'm going to write I squared in parentheses. That part never changes. What would my outer exponent be? What's half of 56? 23. 28?
Yeah.
Okay. 28. So this I squared is negative 1 raised to an even power. Is that going to be a positive 1 or a negative 1? Positive 1. And that would be your simplified answer. Okay, any questions? Okay, I'm going to stop right there.